In this video, I'm going to show you how to find average atomic mass. The only thing you'll need to do here is just follow along with me in the notes that you were given. So far what we've done is we've looked at isotopes with a whole number that's on the upper left side representing the mass of any element. Say for example, if I've got hydrogen with the number 1 up here, that means that it has a mass of 1. And we say in chemistry atomic mass unit. Or say for example, if I've got fluorine and there's a 19 up here, that means that I've got 19 atomic mass units. So far we've been speaking in whole numbers. So the question is, why are we talking in whole numbers when on our periodic table we see elements having atomic masses with long decimals? For example, take a look at copper on your periodic table. See if you can find it. If you can't find it on your periodic table, go to table S and look up the word copper. It'll give you a symbol and your atomic number, and then you can look that up on your periodic table and find that it has a mass listed as 63.55. Do the same thing for iron. If you don't know the symbol for iron, look it up from the name on your table S, and then you'll see where the atomic number is. You can look up the atomic number then on your periodic table. But you'll find that it has a mass listed as 55.85. So what's with the decimals? You see, when we're talking about atomic mass, we're usually referring to one particular isotope, which means how many protons does it have plus how many neutrons it has. So that's a whole number. But when we're talking about the average atomic mass, we're talking about the weighted average of the masses of all of the isotopes that are out there of that element. So average atomic mass, when you think averaging, you think what? Like adding everything up that you have and then dividing by the number that you added together, right? Like say I want to find out what's the average height of 5th graders, and I add up 24 5th graders and I find out that their total height was X, and then what do? You divide it by the 24 5th graders and you get an average. Well, with isotopes and the average atomic mass, it's a little bit different. I'm going to show you now the equation that we use to figure out the average atomic mass. Here's the equation that we use to find the average atomic mass of an element. And what we have to do is we have to take the mass of that isotope times its abundance plus the mass of another isotope of that element times its abundance, and then we keep adding as many as we have. And of course the abundances are always in a percentage. So for example, right now on my lawn there's a big migration of birds happening, and 25% of those birds are robins, and the other 75% of the birds out there are starlings. So when we talk about abundance, we usually talk about a percentage. This is an example of finding the average atomic mass of lithium. There are 2 isotopes of lithium that are common on this earth. There's lithium-6 and then there's lithium-7. The actual mass of the lithium-6 is 6.015. So 7.5% of lithium has a mass of 6.015 atomic mass units here on Earth. The other 92.5% of the lithium on Earth has a mass of 7.016 atomic mass units. What I'm going to do with this information now is I'm going to put it into an equation to find out then, well, what's the average atomic mass of this? What will I have to do? I'm going to have to take the mass of the isotope times the abundance plus the mass of this isotope times its abundance. Here's what I did. Took the mass of 6.015 times its abundance. Now look what I did with the 7.5 number. 7.5%, I take 1/100th of that, and that means I'm going to move the decimal place 2 places to the left. So I moved the decimal place that was here 2 places to the left. And that's what I'm going to multiply by my mass. Notice I did the same thing with the 92%. 92%, I take 1/100th of that, and I move the decimal place over from the 92.5, I move it over 2 places to the left. Multiply those two things together, and you guys know, please excuse my dear Aunt Sally, you're going to multiply first and then add them together and you'll get your abundance. So pull out a calculator and determine that on your own. Tell me what the average atomic mass is tomorrow when you see me. I'm going to leave you now with one more problem for you to try on your own. Here are your numbers. What I'm going to expect you to do is to actually determine boron's average atomic mass and bring it in to me tomorrow, and we'll get started on some more problems. It was nice to welcome you into my home again, and I'll see you at school.